This is the flip learning video for Chemistry Unit 3, Lesson 11, covering exothermic and endothermic reactions. We previously looked at what the features of a chemical reaction were, and you'll know that things like giving out light, giving out heat, producing bubbles by giving off gas, producing a precipitate, changing colour, these are all examples of a chemical reaction taking place. We can also look at chemical reactions being one of two things: exothermic, which is what we'll look at on this slide, or endothermic, which we'll look at in a few slides' time. So as it says here on the slide, exothermic reactions transfer energy to the surroundings. Now, as the name suggests, exo means to give out, and thermic is heat energy. So this shows that the energy that is usually given out to the surroundings is heat energy, and this heat energy will cause the chemicals in the mixture of the reaction to increase. But exothermic don't actually only give out heat energy. Although it says in the name exothermic, giving out heat, they can also release other types of energy, as it says here, such as light being given out, like we saw in the fireworks, or in a firefly, for example, sound energy, which we would also hear in a firework, or electrical energy. So exothermic reactions are not only giving out heat energy to the surroundings, but also other types of energy. Now, the other type of chemical reaction that you might come across is an endothermic reaction. Now, you can see here that the start of this word is slightly different, endo, rather than on the previous slide being exo. Now, this means that in this type of reaction that they take in energy, such as heat, as we can see here with thermic. However, as we saw before with exothermic, they don't necessarily have to just take in heat. They can take in other types of energy, such as electrical energy, which we can see here in this process called electrolysis, which you've looked at before in Chemistry Unit 2. So this is where the electrical energy that is put through this solution is absorbed to decompose the compound that is found within the solution here. So, just to reiterate, endothermic reactions absorb energy from the surroundings, whereas exothermic transfer energy to the surroundings. It's usually heat energy, but not always, as we just said, and if it is taking in heat energy, the temperature of the reaction mixture and the container that it's kept in will decrease, it will go down because it's taking in the energy. An example of this is here, as we can see in this picture. We've got some sweets that contain sherbet in there, and when you eat them, it feels cold on your tongue because this is an endothermic reaction. It's absorbing energy from the surroundings due to a reaction between sodium hydrogen carbonate and citric acid. So this can get a little bit confusing with the start of each of the words, so endo and exothermic. So if you think about it in this way, if exo means to transfer heat or energy to the surroundings, it's very similar to the start of the word exit. And if you think about exit is going out of a building, transferring outside to the surroundings of the building, then that might help you to remember that exothermic give out heat to the surroundings. Now, whether a reaction is exo or endothermic all depends on the energy needed to break the bonds and the energy given out when bonds form in the same reaction. So if we look at the difference between those two things, between the energy needed to break bonds and the energy given out when bonds form, we can look at whether it's exo or endothermic. So here we can see that bond breaking is endothermic. So the breaking of the bonds in a chemical reaction takes in energy from the surroundings. However, any new bonds that are made in that same chemical reaction, that process of making bonds is exothermic. It gives out, releases heat energy into the surroundings. So bond breaking in the chemical reaction, endothermic. Bond making in that same reaction to make the new products is exothermic. It gives out energy. So for a reaction to be classed as exothermic, the amount of energy that is taken in to break the bonds, because remember breaking bonds is endothermic, so the amount of energy that is taken in to break bonds is less than the amount of energy released to make new bonds, because remember making bonds releases energy, exothermic. So it can only be classed as giving out energy overall, being exothermic, if there is less energy needed to break the bonds than there is given out to make the new bonds. And when it comes to endothermic reactions, the opposite is true. So the amount of energy taken in to break the bonds, that endothermic reaction of bond breaking, needs to be more than the amount of energy released when making bonds. So more energy needs to be taken in to break the bonds than is given out after it's made the bonds. So to summarise this video about exo and endothermic reactions, remember exothermic gives out energy, endothermic takes in energy. Bond breaking is endothermic, so it takes in energy. Bond making is exothermic, it gives out energy. Exothermic reactions are a result of more energy from bond making that is given out than is taken in for bond breaking. And endothermic is there's more energy from bond breaking taken in than given out for bond making.